Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 853 car fleet. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes to this problem. So let's get right into it. What problem is asking? Let's understand by taking an example. So this is the test case given to us. We are given a target, a position array. So this is the position array 8, 10, 5, 3, and we have a speed array 2, 4, 1, 1, 3. This is we are given. We have to reach this position, and cars are present at these positions respectively, and they have a speed, some speed. As you can see, they have some speed. And what problem is asking? We have to return the number of car fleets. So what is car fleet? Both car go together, not both car, many car go together, that is called car fleet. There can be many cars, they go at same speed, it is called fleet. So let's take example and see how many car fleets are there in this. We are at position 10. Let's map it correctly. We are at position 10, 8, 5, 3, 0. At 10 we are having speed 2, at 8 we are having speed 4, at 5 we are having speed 1, at 3 we are having speed 3, and 0 we have 1. Yes. So you can see this car is slow, but this is quite fast. This will catch up to the 10 and they will travel as a 1. So this is one fleet, but this is at 5 and with the speed 1, no maths, no physics can make this reach to here. So it will travel slowly, but in the car in the back, which is present at the position 3, with speed 3, will catch up to 5 and they will travel at the same speed like slow 5. As you can see, it is written over here, bumper to bumper at the same speed, catch up to it, and faster car will slow down. You can read over here. This much is good. First fleet, second fleet, and same case is with this. We are at position 0 with speed 1, not to be able to catch anyone. So this is fleet 3. So how many fleets we have? 3 fleets. This is asked in the question. This is what we have to return. I hope this much is clear. So there are some observation that the car at the front should be slow and at the back should be faster and able to catch up to it, catch up to slow car. Condition is that slow is in front. So these two are required conditions. Faster is at back, slower is at front, and both will go at the slow speed when they catch up to each other, or when faster will catch up. This much is clear. So how we are gonna check this? how are we gonna check this, that if they are able to meet with each other or not? Because I just said without any calculation that they will not be able to catch up to them. But how? We can calculate it by basic physics formula, but every time can we do it? I think so. Not. We need something easy, I would say, to judge that they will not be able to catch. What I would say is we are given target position, we are having our current position, and we have our speed. So we would calculate the individual time. Speed is equals to distance upon time. Time is equals to distance upon speed. That's what we are doing over here. We can calculate the time, how much time they will be taking to reach that location. So let's calculate it. Let's copy this. No, copy this. Let's copy this. Twelve minus 10 divided by 2, 1. And 12 minus 8 divided by 4, it's also 1. 12 minus 0 divided by 1, it will take 12. 12 minus 5 divided by 1, 7. And 12 minus 3 divided by 3, it's 9, 3. So let's draw them position wise. And there is also one thing to see or notice when I will write. It is required in order to solve this problem. So 10, 8, 5, 3, 0. It require one whatever seconds or minutes, whatever you want. It will require 7 seconds, 12 seconds. Who will require 7 seconds? 5, 3, this. They will reach their destination in 1 unit of time. So they can go as a 1 because they will collide in between. And why they will collide? Because it will require 7 seconds or whatever to reach to the 12. 3 requires 3 seconds, but 3 will slow down and it is already quite slow. It requires 12 seconds to reach 12. So these three will make fleet. I hope this much is clear. So one thing that we have noticed, time will be used. for the calculation. What calculation? Whether they will go as fleet or not. And other thing is what position needed to be sorted. I sorted in decreasing order in order to depict better, but you can show this in increasing order also. What I am saying is write like this: 3 5 3 5 8 10 12 is the target. You can write like this also. I may have write like that: 3 and 1 1. This is the target that you have to reach. So as you can see, if they are sorted, then it is easy to know which one will be in the fleet. This much is clear. Which one will be in the fleet? So now, what else is left? What else is left? What is left is how, after calculating this time and position, we can store it a vector of pair this in it and sort. But after it is done, then how how we will be determining that these two are in one fleet, because we did by our own intuition, but how we will convert this into the code, what data structure is required, which data structure suit this, which data structure will suit this. Is it something like this happening? That we have our 12, we have our 12. Does something greater than it, does something greater than it present, is present or not? No, I would say. Okay. Is 3 greater than 12? I would say no. 3 is pushed. Does 7 is greater than 3? Yeah. Why we are using stack? Because if something greater than top or the value comes, it means that they are in one fleet. You can see over here, when the 7 comes, it means then it will slow down, which is in the back. And how we gonna know what was present in the back? With the stack, you will say we can use another data structure, but it is fast. We can just see the top in O of 1. We can see the top in O of 1. So we pop it out and put 7. Is 1 greater than 7? No. 1 is greater than 1. 1 is greater than 1. Sorry, 1 is greater than 7. No. And it will be pushed. And after that, 1 is greater than 1. No. So what we are having this. And these are the two, not two, three fleets. That is the required answer. We can get that from stack dot size. Why we are using stack? Because we have to store on the top something greater, or in decreasing order. We need our stack in decreasing order, not greater. We need to store elements in decreasing order. As you can see, it is in decreasing order. And if something is present which disrupt the flow of decreasing, we pop it. Basically, I am telling algorithmically, technically, but what we are doing, we are checking if something is smaller than this. If some time is present in our stack that is smaller than this, why? Because it will give us that someone less is present. That's it. That's it. So let's see the coding part, how it is implemented. So this is, we are taking the size, basic thing. Float. Why we are taking float? Because we are taking time and we cannot round it off. So that's why float. We are taking vector, pair of int and float. You will see now. So we are, what we are doing, as discussed, we are storing the position plus the time. How we calculating the time? Target minus position. We are converting this to float and then divided by speed. We get the time. Then we sort it. I already told you why. Because it is easy to have decision whether they will be a fleet or not. You can see. And also because there are two things. You have position, you have time. You cannot handle two things simultaneously. One thing you have to make, or you have to deal with first. One thing you have to deal firstly, then you have to deal with other. So how we deal with the position in our favor? We sort in it in the increasing order, because something that is present in your back that we have discussed already, then only, and also it is faster, then only they will be in one fleet. That's what we are doing. That's why we are sorting it. And what we are doing, we are taking the time and checking if this time is greater than the top, because we have to check if something is taking less time than us. If it is, then we will take them with us. That's what a slow car is doing. It is stopping the fast car from the back to go forward. That's what it is doing. And that's what we are checking over here. If it is greater than, then smaller will be popped out. Only the leader is put in the stack. That's what I'm saying. Only the leader is put in the stack, and after that we push the leader, whichever is leading the stack. Whoa, fleet. Whichever leading is the fleet. Over here it was 7. Over here it was 1. Or you can say 10. Over here it was 0. That's why I have written this greater than equal to, so that it is 10 that is leading. This one will be popped. So let's submit it for the example test cases. Let's submit it. Yeah, it is running. I hope you learned something. If you did, consider subscribing to the channel, liking this video and sharing with others. And you have to do what you have to do, so keep grinding. You guys are awesome. See you in the next one. Bye bye.